Alright guys, so today's lecture is called The Chemical World, and the reason why this lecture is called that is because everything in the world is made out of chemicals. I know that a lot of times when we think of that word chemistry, we think about like pollution or medicine or explosives or things like that, but everything around us is made out of chemicals. And the better that we understand that, the better we can understand the things that we're learning in this course for this year. So what we're going to do is we're going to talk about a very simple phenomena where we use chemistry and chemistry affect our lives. And the example that we're going to use is soda. So my favorite soda is Coca-Cola, and so that's the reason why we're going to be talking about Coca-Cola. So we all know that when we open soda, it makes that sound, right? That fizzing sound. And I'm pretty sure a lot of you guys already know what causes that sound. That fizzing sound is caused by a chemical called CO2. And there's gases that are dissolved inside of the soda, and that's why when you open it, as those gases escape from the bottle or the can or however you drink your soda, it makes that fizzing sound. That sound is caused by CO2 gases that are dissolved inside of the soda. Okay? Carbon dioxide or CO2, you also don't just hear it, but you also feel it on your tongue when you drink soda. I know that sometimes when you drink like a nice cold soda on a hot day, you feel that tingling sensation on your tongue. That's also caused by CO2. It's caused by carbon dioxide. Okay? Soda is also sweet because of chemistry, because of the chemicals inside of it. So we all know that sugar, there's a lot of sugar inside of soda, and sugar is also a chemical as well. And so, as you guys can tell, just by the example of soda, chemistry affects everything around us, even the smallest things, like the things that we eat or drink, that all is affected by chemistry. Okay, Alright, so like I said earlier, chemicals make up almost everything in our world. So things like soda, textbooks, even your body, the gases that are in this room around you right now, those things are all chemicals. Okay? And the things that chemists study are matter and its interactions. Okay? So we'll talk about what matter is because chemistry is the study of matter and its interactions. And that way, we can understand what we're actually going to be studying in this class. So what is matter? Not what's the matter, but what is matter? So matter is anything that has mass and takes up space. So another way that we can think about that is, I'm sure we all know what mass is, right? Mass is how much of something you have. Okay, so how much of something you have. And some ways that we measure mass is we use grams, we use kilograms. That's how we measure mass. So anything that has mass, anything that you can figure out how much of something you have with grams or kilograms, that is matter. And it's also something that takes up space. So another way we can think of taking up space is things like volume. Some ways that we measure volume are liters. We also measure it in gallons. If you guys remember from your math class, things like centimeters cubed, that is volume. So anything that has mass, anything that takes up space or has volume is matter. Another easy way to think about it is anything that's physical. If it's physical, it's matter. So any type of solid, liquid, or gas, those things are all matter. Okay, so things like cars, those are solid, so they have matter, or they're made of matter. Liquids, coffee is a liquid, water is a liquid, juice is a liquid, that's also matter. And even gases, like the ones that come out of your butt after you don't digest very well, your fart is also a gas, and that's going to make up matter. So matter can be any type of solid, liquid, or gas. There's other types of matter like plasma, but we'll get into that later. Just keep in mind that anything that has mass and takes up space, anything physical, is matter. Okay, so just so that we can look at the opposite side of that, there are things called non-matter. So if matter is anything that has mass and takes up space, non-matter is anything that does not have mass and does not take up space. So you might be wondering, what doesn't, what is not physical? What doesn't have mass? What doesn't take up space? So some common examples that we might engage with every day is things like energy. Energy doesn't have mass and it doesn't take up space. You can't really touch energy. Energy is not physical. And also abstract concepts are also examples of non-matter. So some examples of that would be like freedom, right? So we obviously know that the American flag, it's not non-matter, right? The flag is matter because the flag is physical, right? But the flag symbolizes things like freedom. And freedom is not something physical, right? You can't touch freedom or anything like that. Freedom would be an example of non-matter. You can't touch freedom, so it's non-matter. It's not physical. Okay, so that's one example of non-matter. Another thing would be things like time. Time is not physical. Obviously, we measure time with clocks, and we know that clocks are physical, so clocks would be matter. But time itself is not matter. Time is non-matter because time is not a physical thing. Okay, so anything that's not physical is going to be an example of non-matter. Anything physical is an example of matter. Okay, so I'm sure you guys have all heard this term before, but we're going to talk about something called atoms. So all matter, okay, all matter, anything physical, so anything physical is made of tiny things called atoms. I'm sure you've heard that word before. Okay, and atoms are super duper small. Okay, they're so small that a single drop of water, it contains about 1 billion trillion atoms. Okay, so I know that's a big number and it's kind of hard to think about. So I'll show you guys what that number looks like. So one drop of water contains that many atoms. Okay, that's a huge number, right? I wish my bank account had that many dollars. Even if my bank account had that many cents in it, I'd be super duper rich. I'd be the richest person to ever live. Okay, so that's how small atoms are. That even a single drop of water has that many atoms. So when you think about things like cars or humans or even big things like planets, imagine how many atoms there are in there. There's so many atoms that make up physical things because they are so small. Now, I want to differentiate that with another word that I'm sure you're familiar with, and that word is molecules. Okay, I know that sometimes we use those two words interchangeably, almost like they're the same, but atoms are different from molecules. Okay, so we're going to talk about how they're different. So, how are atoms different from molecules? So, molecules are what are formed when atoms combine together. Okay, so when atoms get combined, they form molecules. So you guys can kind of think of it as atoms would be like the individual Lego blocks, right? So I'm sure you guys have all played with Lego, but each individual piece of Lego would be an atom. So here I drew 4 blocks, so that would represent like 4 atoms. But when you put them together, the thing that you make is called a molecule. Okay, so when you put atoms together, they form molecules. I don't know how many Dragon Ball Z fans there are, but it's kind of like fusion. So when you have Goku, right, with his spiky hair, and then you have Vegeta, he also has spiky hair. So you can kind of consider those two people as atoms. But when you put them together and they fuse together to form either Gogeta or Vegeto, right, the person that they become when they fuse, that would be the molecule. Okay, and if you don't know Dragon Ball Z, then I'm sorry, you can ignore this example right here. You can just stick to the Lego part. But if that helps you understand it, hey, power to you. Okay, just remember that atoms, they combine, they fuse to become these molecules. Okay, so some examples of molecules that you're familiar with would be something like CO2. We talked about it earlier. It's inside of soda. Okay, CO2 is a molecule. This whole thing is a molecule. Okay? But they are made out of different atoms. So here in the middle, we have a carbon atom. We represent that with the letter C. So we have a carbon atom, and then we have two oxygen atoms. Okay, so if you guys notice, we have separate atoms, right? Okay, but when you put them together, when they combine together, they form a CO2 molecule. So just like putting Lego blocks together, just like fusing, when you put these atoms together, they form a molecule. Another example would be H2O, which is water, as you guys all know. And H2O is a molecule. It's made out of an oxygen atom, right? You see the big O in the middle. And then you have an H atom, which is a hydrogen atom. Okay, so basically the point that I'm trying to make is that molecules and atoms are different. Atoms are the pieces that make up the molecule. Okay? Alrighty. So that we'll go back to that word chemical. So what are chemicals? Okay, so chemicals are basically just anything you could touch or hold. Matter. If you have matter, it's some type of chemical. Chemicals is just a word that we use to describe different molecules. Okay, so chemicals is just a word that we use to describe different types of molecules. Okay, so water, we talked about how water is a molecule, right? We have H2O. Okay, H2O is a chemical. CO2 is a chemical. All these things are chemicals. Okay, they're not just like pollutants or poisonous things. Everything is made out of chemicals. Okay, so some examples would be like toothpaste, Tylenol, soda, toilet paper. They're all made of chemicals. You're made of chemicals. Okay, and we just use the word chemicals because it's a simple name to talk about all the different types of molecules that exist. Okay, so just to wrap it all up, what is chemistry? Chemistry is just studying matter. It's studying matter and how it interacts with other matter. It's figuring out how two different types of chemicals will interact with each other. What'll happen when you put two chemicals together? Okay, so some ways it's applied in the real world. Like when you're using metal, just take a look at the things in your house. A lot of those things are made of metal. The way that we put metals together, the way that we forge metals, it's through chemistry. We need to understand how different chemicals can interact to help us make a better metal alloy. Okay, you guys are all aware of the coronavirus thing going on right now. Studying that requires chemistry because the coronavirus is made out of matter. It's made out of atoms and molecules. And we need to understand how it interacts with other matter. Remember, you're made of matter. When we study how the coronavirus affects your body or how a vaccine might affect the coronavirus, that's studying chemistry. Okay? Nuclear weapons or any type of explosives, okay, we make them using what we know about matter, how different chemicals interact so that we can make bigger and more deadly explosions. Okay, even cleaning your toilet, right? I'm sure if you've cleaned your toilet or bathroom before, you've used things like bleach or isopropyl alcohol or things like that. That's the reason why we use those cleaners, is because we know how those chemicals interact with the chemicals in your poop that stick to your toilet. So in order to make a better toilet cleaner, you need to know chemistry as well. Alright, so for today's assignment, just make sure that you guys check on Canvas and that you guys answer the questions. Make sure you guys format your questions or your assignments properly and turn it in by the appropriate due date. Okay, if you guys have any questions, I'm on Zoom right now. Best of luck to you guys, and I'll see you guys next time.